How's it going, guys? Welcome back to another video of 3D printing makery goodness here on Maker's Muse. So you've got something awesome designed and you want to get it printed. So one of the first questions you'll probably ask after how much is it going to cost is how long is it going to take? And this is a really vague question. 3D printing is not a fast process. It does take quite a while, but hopefully I can clarify some of the reasons of why it takes a while, and hopefully I'll be able to do that and stop you leaving things too late for your final hand-ins. So when it comes to assessing how long a 3D print is going to take, there's 5 factors involved. First, there's file preparation, then there's the print queue, machine preparation, the printing itself, and then finally post-processing. File preparation is something you can do on your end to ensure your print is completed in a timely manner. So if you submit an STL file to a company that's full of errors, or it's impossibly thin geometries that can't be 3D printed, they're going to have to fix that file for you. And they'll either do that at an additional cost, or it will mean that your print takes much longer to complete. So when you're designing things, make sure you design them with the physical object at the end in mind. And a good example of this is architectural prints. So if you get an architectural model and scale it down to 1 to 200, those walls become paper thin. So you need to artificially thicken that file before printing. So you can either do this in a really expensive software like Magix, which has a shrink wrap tool, but not many of us have $4,000 to spend on software. So you can also do it in MeshMixer, which is a free tool, and you can check out my tutorial on MeshMixer here. I would also suggest steering well clear of SketchUp. I'm sorry, I know it's got a big fan base, but it makes the worst STL files and mesh files I've ever seen. So if you're just starting out, I'd suggest learning something like 123D, or if you've got a little bit of money, try Cubify Design. It's like a really cheap SolidWorks and definitely one worth learning and makes very good STL files. And then there's the print queue. Pretty simple really. You submit your file and it's added to a queue for printing. So most companies will have something like a 7 to 10 business day turnaround for SLS or SLA parts. But when it comes to the end of semester deadlines, this queue can explode because everyone has the same job to do, same projects to do, and they'll submit their files all at the same time, all at last minute. So take it from me, I did industrial design at UTS for 4 years. Submit your file early, like rush to get it done, and then when it's printing, do your documentation and your presentation work. Don't wait till the last minute like everyone else to get it submitted, because then it's added to a very big print queue and you might not even get it back. Next is machine prep. So if you need a different color or material, this takes time to change. So in the case of the object systems, for example, changing from a white to a black resin requires the machine to be purged. And all of this resin is wasted during the purging process, which costs a lot of money, and the company might charge you this. And if they don't charge you for it, it'll take a long time. So keep that in mind. For FDM, often the company will have, white, black, red, blue, whatever. But if you want something clear or rubber, don't try to print it as clear or rubber. There is processes that promise it, but they're not really that clear, or not perfectly clear, or a bit yellowy, or not very rubbery. They're actually sort of like felt almost. What you want to do instead is cast a master. So you 3D print the master and cast it into a urethane or a silicon, so a clear urethane or a flexible silicon or flexible urethane. And by doing that, you can save yourself a lot of money and a lot of hassle than trying to actually print it directly. And then there's the actual print time. So this is where things can vary wildly. So there's a lot of different processes out there. If you're confused about the different processes, check out my process video, which should help clarify some things. For machines like the SLA and SLS machines, it's not the actual sintering or curing of the layers that takes a long time. That can be done in a matter of seconds. It's actually the changing of layers, where they might wipe a new layer of powder on, or move the bed and let a new layer of liquid resin go on, which takes the time. So for SLS, you're looking at about 30 millimeters per hour build time in the Z direction. That's the up and down direction. That's at a good average sort of speed. For SLA, it's significantly slower because the SLA layers are so much smaller. You can get 10 micron SLA layers. So SLA prints can take weeks if they're a big SLA printer and the detail's that low. Whereas SLS, you're usually looking at around 24 hours for a full build, but you also need about 6 or so hours for the cool down of the parts, so you can't take them out straight away when the machine's done. So that also needs to be accounted for. And then there's FDM, which is the most common low-end 3D printing process, and FDM is really hard to predict the print time. So what I want to do is just show you a quick demonstration with some cubes, which might help clarify some things. So here I've got a 20 by 20 millimeter cube. It was printed on my Mini in about 10 minutes. It was on the fastest setting, 250 micron layer heights, and the hollowest fill. So it's almost completely hollow with a very slight honeycomb fill inside. So this took 10 minutes. 2 of them takes about 20 minutes, 3 of them about 30, and so on, so on. It actually takes a little bit longer than that because the machine has to move between the points of each object when you're printing multiples. So it's actually not really economical as such to print multiples at once. It doesn't get quicker, but it is much more convenient because you don't have to go back to the machine every 5 seconds to hit print again and clear the build plate. And then there's scaling. So this 20 by 20 cube took 10 minutes, but if it needs to be scaled 200%, you have it scaled in 3 dimensions. That dimension, this dimension, and then of course filled in. So as you can see, it's not going to take twice as long or use twice as much material. It's actually going to take 8 times as long roughly and use 8 times as much material. Again, I'm saying roughly because things aren't really linear in 3D printing. So when people ask for things to be scaled twice the size that they originally are, they get often confused and sometimes insulted by the prices that I come back to them with because it's so much more expensive. But that's just how it is. The volume will increase, 8 times for a 200% scale. So keep it in mind, if you can get your prints done smaller, you'll save yourself a ton of cash and the prints will take much less time. Another influencing factor for FDM is the complexity of the print. So this iconic pony, which is in all of my videos, took about 6 hours to print, and the reason it took so long is I had to turn the speed way down on the printer, otherwise it would have knocked the parts off, and it had lots of support materials that all had to be pulled away, and it took a long time to print that support, and of course I had to be very delicate with it, otherwise it would have broken the part. And then there's SLA. So this little figure from Chivalry took about 6 hours to print. He's only 30mm high. And the reason it took so long is because SLA is a very detailed but very slow process. There's probably more layers in that SLA print than in the pony print. And finally there's post-processing. So there's no 3D printing process in existence that lets you just take the part out of the printer and it's finished and perfect. I'm so sick and tired of 3D systems showing these videos on Cubify, which just show you taking the part out and they're all like, yeah, it's all done. It's a lie. So it changes depending on the different process. For example, with FDM, you either have support material that dissolves away, so you leave it overnight in a chemical bath, or you break it away mechanically. So depending on how complicated the shape is, this can take hours sometimes because you don't want to break the part as you're taking the support material off. For SLA prints, you have to post-cure it and harden it with a UV light. And you also have to mechanically remove the support, which is very tedious because the parts are so delicate and brittle. And then with SLS, it's probably the easiest. There's just the dusting off of the powder, but there's the cooling down process that I mentioned. So you can't just take them out of the printer as soon as it finishes. You have to let the whole build cool down from the high temperature that it's at for printing to a room temperature for taking the parts out. If you rush this, the parts will warp and deform, which you really don't want. And let's not forget the fact that, like any machine, they can break down. So even the most expensive SLS machine can still have a build failure, and it's like a paper jam except 1,000 times worse. You have to start again from scratch. You have to throw away all those rejected parts and probably some of the powder and go again. So with FDM, if it fails, 26 hours into a 27-hour build, you can't restart it. The machines aren't really smart enough to know where they failed and to continue. You have to just scrap it and start again. So allow time for things to go wrong in your printing process and your lead times, because things will go wrong and they go wrong all the freaking time. So obviously the take-home message here is give yourself plenty of time, but I know it's not always possible. So when you're designing your things, keep in mind the fact that you're printing a physical object, and keep in mind what process you want to go with. So if you're designing a really intricate grid-like structure, don't print that on FDM because it's going to be full of support. Consider spending a bit more money getting it printed on SLS, which will look a lot better. You're unlikely to get a part back that some prat broke a bit off and it looks terrible. And obviously having your own 3D printer helps a great deal. I love my Art Mini oh so much. It has saved me so many times, especially if you need to print something at 2 AM on a Monday morning. But not everyone's so lucky, so consider getting a printer if you really end up using 3D printing a lot. But if not, keep in mind the lead times. And that's it. Thanks for watching, guys. As always, I really appreciate it. And if you enjoyed this video, maybe consider subscribing to see more future 3D printing videos. Let me know in the comments your experiences and advice with 3D printing lead times. I have been stung many times and I'd love to hear your stories. But I really look forward to seeing you again here at Maker's Muse, and I'll see you around. Thanks, guys.